Hello everyone. Welcome back to our channel. Today, we are diving into an exciting project using Xilinx Vivado, where we'll be simulating a lab experiment for the design of an 8-to-3 encoder, both with and without priority, and a 2-to-4 decoder. This experiment is part of the CMOS VLSI Design Laboratory for B.Tech 3rd year 2nd semester, following the JNTUH curriculum for ECE students. We'll walk you through each step of creating a Vivado project for this specific lab experiment. Don't forget to hit the like button, subscribe to our channel, and ring that notification bell so you never miss out on our educational content. So, let's get started. Open Xilinx Vivado by clicking on its icon from your desktop or Start menu. Once Vivado is open, click on Create Project to start a new project setup wizard. Press Next on the introductory dialog box. Assign a name to your project, such as encoder_decoder, and specify the location where the project will be stored. Click Next to proceed. Ensure RTL project is selected. Confirm that Do Not Specify Sources at this time is checked since we'll be creating new source files directly in Vivado. Click Next. In the default part screen, select the FPGA board or part you will be targeting for this project. You can use the filters or search function to easily find your device. Click Next after making your selection, then Finish to create your new project. In the Project Manager, under Sources tab, and click on Add Sources. Choose Add or Create Design Sources, click Next, and then click Create File. Enter the file name for your first Verilog source, such as encoder_8to3.v. Set the file type to Verilog, and click OK. Repeat this process for additional files, encoder_8to3_priority.v and decoder_2to4.v. We shall not use automated code generation. We will add the codes ourselves. For each created file, input the Verilog code directly into the Vivado editor that opens for each file. Save your progress. In the 8-to-3 encoder without priority, our code takes 8 input signals and converts them into 3 output signals. This means no matter which of the 8 inputs are active, our encoder will generate a unique 3-bit output. In 8-to-3 encoder with priority, our code not only translates 8 inputs into 3 outputs but also decides which input gets priority if multiple signals are high. Lastly, we have our 2-to-4 decoder. This piece of code reverses what our encoders do. With just 2 input signals, it produces 4 distinct outputs. Similarly, add a simulation source by clicking on Add Sources. Choose Add or Create Simulation Sources, and then click Create File. Name your testbench file, like tb_encoder_decoder.v, ensuring it's set to Verilog. Input the necessary Verilog testbench code and save the file. Let's look at how we test our encoders and decoder with specific inputs and what outputs we expect. In our test, we input 8B00000001 to the encoder, expecting it to identify the first line as active. For the priority encoder, 8B10010001 tests how it selects the highest priority input. The decoder receives to be 01, and we look for 4B0010, indicating the second option is chosen. These precise inputs and expected outputs help us verify our design's accuracy in handling different scenarios. With the test bench file open, navigate to Flow Navigator, Run Simulation, Run Behavioral Simulation. This will compile all your Verilog files and run the simulation based on your test bench. After the simulation runs, use the waveform viewer to inspect the results. Verify that the outputs match expected results based on the input scenarios defined in your test bench. In the Flow Navigator on the left side, under Project Manager, click on Run Synthesis. Vivado will process your design files to synthesize the circuit. This may take a few minutes. In the Xilinx synthesis process, your design code is transformed into a gate-level schematic, optimizing for performance and resource utilization. First, the process reads and interprets your HDL, hardware description language, files, analyzing the design's structure and functionality. Next, it optimizes the design by reducing complexity and improving speed, ensuring it fits within the target FPGA architecture. Finally, the synthesized design is mapped to the specific logic elements of the FPGA, ready for further simulation and eventual implementation on the hardware itself. Upon completion, a dialog box will appear. Ensure to check Run Implementation and click OK. The implementation process starts automatically after synthesis if you selected the option in the previous step. This step converts the synthesized design into a device-specific layout. Wait for the implementation to complete. This might take a while depending on the complexity of your design. In the implementation phase following synthesis in the Xilinx toolchain, the design undergoes placement and routing, where synthesized components are assigned specific locations on the FPGA and interconnected. This phase is crucial for meeting timing constraints and optimizing resource allocation. Various reports are generated throughout, including the utilization report, which details how much of the FPGA's resources are used, the timing report, assessing whether the design meets its specified speed requirements, and the power report, estimating the design's energy consumption. These reports provide invaluable insights for designers to refine and enhance their FPGA-based projects, ensuring optimal performance and efficiency. After implementation, with the implemented design open, in the Flow Navigator, under Project Manager, select Schematic. This opens the schematic viewer. Review the simulation results, synthesized schematic, and implementation details to ensure your design meets the desired specifications and performance criteria. Make any necessary adjustments to your design based on this analysis. Save your project and all changes by navigating to File Save Project. Close Vivado by selecting File Close Project or File Exit when you are finished with your session. And that wraps up our tutorial on simulating a lab experiment for the design of an 8-to-3 encoder and a 2-to-4 decoder using Xilinx Vivado. We hope you found this guide informative and easy to follow. With these steps, you are well on your way to mastering VLSI design and simulation using one of the most powerful tools in the industry. For more details, source code, and the lab manual related to this experiment, make sure to visit our webpage at research1.fun. There, you'll find a treasure trove of resources to further your understanding and skills in VLSI design and many other areas of electronics and communication engineering. If you enjoyed this video and learned something new, please consider giving us a thumbs up and sharing it with friends or classmates who might also find it useful. Your support means the world to us and helps us create more content like this. Got questions or suggestions for future videos? Drop them in the comments section below. We love hearing from you. And don't forget to subscribe and hit the bell icon so you never miss out on our upcoming tutorials and guides. Thank you for watching, and we'll see you in the next video. Happy designing!